Hello everybody and welcome to this video. In today's video we are going to discuss about while loops in R programming language. So here we are going to discuss while loops. Before we discussed about the for loops. However, while loops are going to be... Hello everyone and welcome to this video. In today's video we are going to learn about some matrix manipulation in R. So specifically, we are going to learn how to add a new row, how to add a new column, how to remove the first row or any row that we are looking for, or how to remove any column and reshape our matrix. So first of all, we are declaring our matrix using the matrix function. The name of my matrix is D. And I'm having numbers from 1 to 12. So I have 12 elements in this matrix. They are from 1 to 12, meaning that they are 1, 2, 3, etc. until 12. And we are having 3 rows. So n row means that the number of rows we need to decide about it. So 12 divided by 4, the number of elements divided by the number of rows, it will result in the number 4, which is the number of columns. So first of all, we're going to print this matrix D. Looking at the output, we see that this is our matrix D. We see that there are 3 rows as expected and 4 columns, 1, 2, 3, and 4. So we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12. So this is my matrix D. Now I would like to learn how to add a new row. So as you see here, we are having 3 rows only in this original matrix. But as you see here, I have the same matrix, but a new row is added. Row 4 is added and all the elements are 0. How can we do that? In order to do that, I'm using the rbind function. And then I'm having the numbers 0 there to be added. And I use a D here as to call for the rbind function. So I call the rbind function and D. So then I decide about the numbers that I would like to be included in the new row. And all of this is assigned to D with new row. Okay. So here I call the rbind function for the D matrix. Okay. And we are adding these values as the new row. Okay, so this is the row binding, in fact. So this rbind is the row binding function. It is going to be called for the matrix D that we initialized here. And then these are the values that are going to be added to as a new row for this matrix. And then we print this matrix here in the output. Looking at the output, we see that exactly a new row is added to the original D matrix and all the values are 0 because we decided them to be 0. Then we are having the new column being added. So this new column that we would like to be added, we are going to add it to the matrix D. So this original matrix, 3 rows and 4 columns, we're going to add a new column here. Then we are going to use the cbind function for the matrix D, and then these are the values that are going to be added for the new column 10, 20, and 30. All of this is assigned to a new name matrix called D with new col, and we print this in the output. So when I look at the output and compare this newly generated matrix compared to this one, we see that a new column number 5 is added and the numbers that are in the new column are 10, 20, and 30. So this is how we can actually add a new column and add a new row so far. Then we would like to remove the first row. In order to do that, we simply call the D matrix and we are having in the square bracket, we are going before comma, we are going to have the number -1. It's going to remove the first row of the matrix D because when we are writing the number before the comma, Okay, it means that we are dealing with rows. If I write it after the comma, it means that I'm dealing with the columns. So in this example, I'm dealing with rows. I would like to remove the first row. I type down -1. If I want to remove the second row, I type -2. If I want to remove the third row, I type -3, for example. For the D matrix, and all of this is assigned to a newly generated matrix called D minus row. So I print it in the output. And looking at the output, we see that now the third row is not there anymore here. So we see that it has been removed indeed. In order to remove the column, as we explained, after the comma, we are going to put the negative numbers. The first column, -1. If you want to remove the second column, -2, etc. And this is assigned to a matrix called D minus col. And then we are going to print that in the output. And looking at the output, we see that here now, instead of having the original D matrix with 4 columns, we are only having 3 columns. Okay, so the last column having 10, 11, and 12 are being removed from this. Okay, and now I would like to reshape my matrix, meaning that now I have 3 rows and 4 columns. I would like to have a matrix of 4 rows and 3 columns. So I would like to reshape it. I call the D matrix. I call the matrix function for the matrix D. And I mentioned that, okay, now I would like to have the number of rows to be equal to 4 and number of columns to be equal to 3. All of this is assigned to reshaped D matrix. Looking at the output, we see that now we are having 4 rows and 3 columns instead of having 3 rows and 4 columns. So in this video, we learned how to manipulate our matrix, how to add and remove rows and columns, and how to reshape our matrix. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about some special types of matrices in R. So first of all, we're going to discuss matrices that are like diagonal matrices. Meaning that I would like, for example, to have a matrix that is 3 by 3, and in the diagonal we're going to have only number 1. In order to do that, we are going to have this keyword diag, and inside parentheses, when we want to have the 3 by 3 identity matrix, we're going to put number 3 there. If we want it to be 4 by 4, we're going to put number 4 there. And this is assigned to diag matrix 1. So when I print this one, I see this in the output. So looking at the output, we see that it's a 3 by 3, 3 rows and 3 columns matrix. And we are having a diagonal of number 1. And so we are having number 1, number 1, and number 1, and the other elements are number 0. So this is basically how we can do the diagonal matrix, a 3 by 3 diagonal matrix that are having values of 1. Then we can have diagonal matrix with custom values. So I'm going to have, for example, the diag function to be called, and then for the C, I'm going to put these 3 numbers. So I would like to have a matrix that is 3 by 3 because I'm having 3 numbers here on the diagonal, meaning that it's a 3 by 3 matrix. If I put 4 numbers in the diagonal values, it means that it's a 4 by 4 matrix. So I would like a matrix that has the diagonal of 2, 4, and 6. So then after that, I print the diagonal matrix 2. So all of this is assigned to diagonal matrix 2, and then I print it. So when I look at the output here, you see that I have a matrix that has a diagonal of these numbers 2, 4, and 6 as we identified here. And because we chose 3 values, we are having a 3 by 3 matrix. So if I add another number, for example, number 8, and I run the code one more time, you see that now I have a 4 by 4 matrix. Why? Because I mentioned that I would like to have 4 values on the diagonal, meaning that it must be a 4 by 4 matrix to be able to have 4 values on the diagonal. So 2, 4, 6, and 8, all of them are being shown there in the diagonal. Then I would like to create a matrix of zeros. in order to do that, I call the matrix function. I put the value 0, and then after first comma, I'm going to have the number of rows, and after the second comma, I'm going to have the number of columns. All of this is assigned to 0 matrix. It is going to create a 3 by 3 matrix and put 0 for all the elements. Looking at the output, so all of this is assigned to 0 matrix, and then I print the 0 matrix in the output. So we see that everything in this 3 by 3 matrix is 0. So all the elements are having the value of 0. Then how can we have a matrix of ones? So I would like to have a 2 by 4 matrix, and all of the values I want to be 1. So I call the matrix function. I put number 1 there, so all the elements will be 1. And number of rows are 2. I chose to be 2. And then I have the number of columns to be 4. So I have 4 columns here, as you see, and 2 rows. And all of this is assigned to a matrix called a ones matrix. And then I print it here in the output. Looking at the output, we see exactly what we expected is being printed in the output. So in this video, we learned how to have a diagonal matrix. So we can have an identity matrix, we can have diagonal with custom values, and then we can have matrix of zeros and ones. Thanks for watching. Hello everybody, and welcome to this video. In this video, we are going to learn about some matrix functions. First of all, I have a matrix called E. I use the matrix function to generate randomly 9 values for my matrix E. So in order to generate random values, I have the R norm, and I write down number 9 there, meaning that I would like to have 9 values being generated. Then I'm having the number of rows to be 3, so we are going to have a random 3 by 3 matrix. Why 3 by 3? Because the number of rows equals 3, so we are having 9 elements divided by 3. It will result to 3 columns as well. So firstly, I print this matrix E in the output. So as you see here, matrix E is being printed 3 rows and 3 columns. Some of the numbers are negative and all of them are randomly generated. Then I would like to calculate the sum of each row. So I would like to know the sum of values in the first row, the sum of values in the second row, the sum of values in the third row. So I use the row sums for the E matrix. Looking at there, we see that these 3 numbers are being printed. So this is the number of the row sum of the first row, and this is the number of the sum of the second row, and this is the number of the sum of values in the third row. Okay, so we use the row sum and assign it to row sums variable, and we print it here in the output. Then I have the call sums for the E matrix, meaning that it is going to calculate the sum of matrix E. And you see it here in the output. So here, this number 3.21 is the sum of this number plus this number plus this number. So all the numbers in the first column. Okay. So this number 1.83 is the sum of these 3 numbers, okay? This one, and this one. And then we are having this number, which is the sum of this number plus this number and this number, meaning that the 3 values that are in the last column. So this is also how we can calculate the sum of the columns. The first number is the sum of the values in the first column, this one for the second column, and this one for the third column. So next we would like to have the calculation of averages, or let's say the means of rows and means of columns. In order to calculate the means of each row, I call the row means function for the E matrix, and there we are going to assign it to row means and print it in the output. So we see that this is the number which is the mean of these 3 numbers, which is the first row. This is the mean of the second row values, and this is the mean of the third row values. Okay. Then we are having the row means function, column means function for the E matrix, and we are having these three values. So this number is the mean of the values in the first column, which is this one, and this one. This one is the mean of the values in the second column, which is this one, and this one. And then this number is the mean of the values in the third column. So these are these three numbers. Okay, so this is the number which is the mean of this number, and this number. Please note that they are negative numbers. This is why we're having the mean as a negative number. So in this video we learned how to generate randomly a matrix. Then we learned about how to calculate row and columns sum. And finally, we learned how to calculate row and column means. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn a little bit of matrix algebra. So firstly, we are going to create a matrix. We're going to calculate its inverse. We're going to verify its inverse, and we're going to know the matrix rank in the end. Okay, so now the name of my matrix is C. I call the matrix function to have a matrix with 2 rows and with these values. So I would like to have a matrix with 4 elements, so 2, 1, 4, and 3. In order to have the elements there, I use the C there, and I choose to have 2 rows. So 4 elements divided by 2, the result will be 2, which will be the number of columns. So firstly, I print the matrix C in the output. So we see that here I have a 2 by 2 matrix, and the elements are 2, 1, 4, 3, as we chose here, 2, 1, 4, 3. Now, if I want to calculate the inverse of the matrix, simply I call the solve function for the matrix C and assign the output to inv_C matrix. So when I print it, I see this one here in the output. So looking at the output, we see that here is the calculated inverse version of the matrix C. So this is how we can actually calculate the inverse of a matrix, by calling the solve function. And in order to verify that it's an inverse matrix, so it's the correct inverse matrix, simply we are going to have the round function for the matrix C, and we're going to have percentage star and percentage operator or sign, let's say modulus, multiplication, and again the modulus operator of the INVC. So basically we are multiplying these two matrices, matrix C and the inverse version of this matrix, and it is being assigned to a new matrix called identity. So this should result in an identity matrix. So when we print that in the output, we see that indeed we are having a matrix with the diagonal of 1 and 1. So it means that we could verify the inverse version of our matrix C. Okay. Now, in order to calculate the rank of our matrix, we are simply going to call the QR function for the C matrix, and then the $sign rank is going to calculate the rank of our matrix. It is assigned to matrix rank, so this is the name of our variable. And finally, we print that variable, so it's going to show this message in the output, which is number 2. So the rank of our matrix is number 2. So in this video, we learned about how to do some algebraic operations with our matrices. So we learned how to create a matrix, how to calculate its inverse, how to verify its inverse, and how to calculate the matrix rank. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn about matrix mathematical operations in R. So first of all, we would like to create 2 matrices. The first one is called A. I call the matrix function to have numbers from 1 to 4, and I would like to have 2 rows. Okay, So when I mentioned that starting point is 1 and ending point is 4, it is going to include numbers 1, 2, 3, and 4. So there are 4 values. And when I specify that I would like to have 2 rows, 4 values in 2 rows, so 4 divided by 2, the compiler understands that we also have 2 columns. We don't need to necessarily declare it, but we can also do it if we want. Then I would like to have the second matrix that is called B. It starts from 5, ends at 8. So 5, 6, 7, 8. 4 values. The number of rows, we are having 2. So 4 divided by 2, we see that there are also 2 columns for matrix B as well. So then I print matrix A and B using the print function. So simply I write down matrix A message and matrix B message. And then I print matrix A and matrix B. So when I look at the output, this is the matrix A. So 1, 2, 3, 4. These are the values 1, 2, 3, 4. So 2 rows. This is the first row. This is the second row. This is the first column. And this is the second column. Then we are having the matrix B. And you see that 5, 6, 7, 8. So this is the first row. This is the second row. This is the first column. And this is the second column. So we created 2 matrices. Now I would like to have the matrix addition. So A plus B is going to give me the element-wise addition of the matrix, meaning that we are going to create a new matrix. So the first value is 6. That comes from the first value, first element, let's say, of matrix A plus the first element of the matrix B. So 1 plus 5, it's 6. Then we are having 2 plus 6, it is 8, as you see here in the new matrix. 3 plus 7, it's 10. 4 plus 8, it's 12, as you see it here in the output. So this is actually how we can have the matrix, the new matrix that is called matrix addition. So we are having this message firstly, and then A plus B. Then we are having this message, matrix subtraction, and A minus B is being printed in the output. So A minus B is going to result in this matrix. So A is this one and this is B. 1 minus 5, it will be minus 4. 2 minus 6, it will be minus 4. 3 minus 7, it will be minus 4. 4 minus 8, it will be minus 4. So we are having a new matrix that is created from the subtraction of A and B. Then we can have the element-wise multiplication. So here we are having A multiplied by B. So looking at the output, we are going to see the element-wise multiplication. So we are having number 5 here. So 1 multiplied by 5, it's 5. 2 multiplied by 6, it's 12. 3 multiplied by 7, it's 21. And 4 multiplied by 8, it's 32. So this is the element-wise multiplication. But we can have the matrix multiplications as well. So for that, we are going to have A, and then the modulus operator, star, then the modulus operator again, then matrix B. This is going to help us to have the multiplication of 2 matrices, meaning that the matrix A is going to be multiplied by matrix B, not element-wise, the normal multiplication, which will result in this matrix as you see here. Okay, so this is basically how we can have it. So for example, to have number 23, we need to have 1 multiplied by 5, which will be 5, plus 3 multiplied by 6. So 3 by 6, it's 18, plus 5, it will be 23, as you see it here shown there. So this is how we can have math operations in matrices in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to have the scalar multiplication of a matrix exponentiation, element-wise, and then the comparison operations of 2 matrices. So first of all, I create the matrix A. Calling the matrix function, I would like to have 2 rows and I would like to have 4 elements there from 1 to 4. So starting point is 1, ending point is 4. So 1, 2, 3, 4. Okay. So meaning that I would like to have from 1 to 4, meaning that there are 4 elements, and we chose to have 2 rows. It means that we are going to have 2 columns as well, because the number of elements are 4, and then number of rows is 2. So 4 divided by 2, it's going to have 2 columns. Okay. Then I create my matrix B here. I call the matrix function. I call the rep function also to have the repetition of number 2 4 times. So I would like to have 4 number 2s. Okay. And then I choose the number of rows to be 2. So firstly, before doing anything, I print the matrix A and B. So looking at the output, this is matrix A. So number 1, 2, 3, and 4, all of them are there. And then I have the matrix B, which has 4 elements, and all of them are 2, as we decided here. And we're having 2 rows and 2 columns for both of the matrices. Now, I would like to have the scalar multiplication. In order to do that, we are having, for example, number 3 to be multiplied by matrix A. This is the matrix A. So number 3 is going to be multiplied to all the elements of matrix A, and the new matrix is going to be written like this. Okay, so we put it in the print function, so it's going to be printed in the output. So number 3 is multiplied by 1, the output will be 3, so we see it's there. Number 3 is multiplied by 2, the output is 6, it's there. Number 3 multiplied by 3, it's 9. Number 4 is multiplied by 3, it's 12. So this is the matrix that is created from the multiplication of scalar 3 by matrix A. Okay, so this is how we can have it in the output. Also, we can have the matrix exponentiation, meaning that, for example, we can raise the elements of matrix A, all of them, to the power of 2. So it's an element-wise operation. So, for example, here, number 1 to the power of 2, it's 1. 2 to the power of 2, it's 4. 3 to the power of 2, it's 9. And 4 to the power of 2, it's 16. So all of them are raised to the power of 2, element-wise. So this is how actually we can do it. We can have the A and then the hat sign and then number 2. We could have number 3, number 5 as we wish. So just remember that it's an element-wise operation, meaning that it's going to raise all the elements 1 by 1 to the power of 2. Okay. Now I would like to have the comparison operation between matrix A and B. So we would like to see if matrix A equals B or not. So this is the output actually. We are having false, false, true, and false, meaning that it is going to see if the first element of matrix A equals the first element of matrix B. Is it equal? No. So the output is false. So the second element of matrix A equals the second element of matrix B. Is it true? Yes, it's true. So we have the true in the output. So 3 equals 2. No, it's false. 4 equals 2. No, it's false. So it's going to compare the numbers 1 by 1 of each element to see if they are equal or not. If they are equal, it returns true, which is the case here. Otherwise, it's going to return false. So this is how we can have the comparison operation. Also, another example is being shown here. I would like to see if A is greater than B. So we see that the output is false, false, true, true. So let's see. So it says 1, is it greater than 2? No, so it's false. 2, is it greater than 2? No, so it's false. 3, is it greater than 2? Yes, it's true. So we are having a true in the output. And 4, is it greater than 2? Yes, so we are having the true in the output as well. So basically, this is how we can have the comparison operations as well, along with scalar multiplication and matrix exponentiation. Thank you for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to access a single element, entire row, and entire column of a matrix. And also, we're going to learn how to have access to a submatrix and logical indexing. So firstly, I would like to create my matrix called mat, and I call the matrix function starting from 1 and ending at 12, and we're going to have 3 rows there. So I have 12 elements and I would like to have 3 rows. So 12 divided by 3, it will result in 4 columns. So we don't need to specify the number of columns if we indicate the number of elements, the elements actually. So, and also the number of rows. The compiler can calculate the number of elements divided by the number of rows. So it can itself calculate the number of columns itself, but we can also specify it if we want to. Simply, we can specify it like the number of rows here that we specified, okay? Then I print the mat matrix. So we see that we are having 3 rows and 4 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12. So these are the elements of my matrix. Now I would like to access only a single element. So the element at row 2 and column 3. So the element at row 2, this is the entire row 2, and column 3. It will result in number 8. So if I want to access this number 8, simply I need to give this address to the compiler. So I would like to print the element that is at row 2, column 3 of the mat matrix. Okay, so this is how we give the address. So the element at row 2 and column 3 of the mat matrix, we're going to print that. So we see that here number 8 is being printed in the output. Okay, now I would like to access the entire row. I would like to have the access of the second row, and I would like to print all the elements in the second row. In order to do that, simply I call the second row, and after comma I put nothing because I would like to have the entire row for the mat matrix, and I'm going to print that. When I run this, we are going to have 2, 5, 8, 11, exactly the numbers that are in the second row of this matrix. Okay, what if I want to print the entire column? For example, column 3, the third column, I would like to print the entire column 3. So this is 7, 8, and 9. This is column 3. In order to access that, simply we are having the mat matrix being called. Before comma we put nothing because before comma it is for the row. After comma it's for the column. I put column 3. So I would like to have the values in column 3. I put column 3. I put number 3 there. If I want the numbers in column 4, I simply put number 4 there. So, and then all of this inside the parentheses of the print matrix. So we see that the third column is being printed in the output. So we are having 7, 8, and 9 in the output. Okay, now I would like to have access to a submatrix for rows 1 and 2 and columns 2 and 3. So rows 1 and 2, so this is row 1, this is row 2, columns 2 and 3, meaning that I would like to create a new matrix with numbers 4, 7, 5, 8. So I would like to create a submatrix of the original matrix for the rows 1 and 2 and columns 2 and 3. Okay, so there are 4 elements there. Simply, in order to do that, we call the mat, which is the original matrix, and then we are having before comma, which is for rows. I put from 1 to 2 because I would like to have rows 1 and 2. So from 1, okay, row 1 and row 2. And after comma, we put 2 and 3, which is going to be for columns 2 and 3. So columns 2 and 3. This way, we are going to have a submatrix with numbers that are both in row 1 and 2 and columns 2 and 3, meaning that 4, 7, and 5, 8 they are going to be printed in the output. So when we look at the output, the submatrix is here. So we are having 4, 7, 5, and 8. So this is the submatrix that we just created. And finally, we would like to have logical indexing. I would like to, for example, print the elements that are greater than 5. So I would like to print only the elements that are greater than 5. In order to do that, I call the mat matrix, and I would like to mention that for each element in the mat matrix that is greater than 5, print it for me in the output. So we see that all the numbers that are greater than 5 from the original matrix, they are being printed. So 6, 7, 8, 9, 10, 11, and 12, all of them are being printed in the output. So in this video, we learned how to access a matrix, for example, a single element, an entire row, an entire column, to access a submatrix, and how to do logical indexing. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to create a matrix with different field patterns. So we can fill a matrix with filling it by row or by column. We're going to learn these two filling patterns in this video, and then we're going to learn about how to check matrix properties like the dimensions, number of rows, number of columns, and total elements. Let's dive in. So first of all, I would like to create my matrix by row to be filled by row. So this is the name that I choose, matrix by row. I call the matrix function. I want the starting point to be 1, the ending point to be 6. So from 1 to 6 are the elements of my matrix. I would like to have 2 rows. So this is the end row, meaning that number of rows. So I would like to have 2 rows. So how many columns will I have? So the number of elements. So I start from 1 to 6. So I will have 6 elements divided by the number of rows that I just chose here. It will be 3, so 3 will be the number of columns. So this the number of columns can be calculated through these two values by compiler automatically. Then I would like to mention that, okay, I would like to fill this matrix by a row. So I put by row equals true, meaning that I would like it to be filled by row. And if in case you would like it to be filled by column, simply you do the same thing, but here by row equals false. So it will fill them by column. So what do we mean fill by row and fill by column? So let's print these two matrices and look at the output. When I look at the output, the first matrix, which is the by row version, okay, these are the numbers 1, 2, 3, 4, 5, 6. So it will increment by row. So in the first row I have 1, then 2, then 3, and in the next row I will have 4, 5, and 6. Okay, but when I fill them by column, it means that 1 is the first element, then 2 is in the same column but next row. Then I have number 3 and 4, 5, and 6. So when I talk about filling it by row, it means that I will fill it from left to right in the incremental order. But when I say I would like to fill it by column, it will be in each column. Okay, so 1, 2, 3, 4, 5, 6. So this is what I mean by fill by row and fill by column. So this is how we can have it. Then we would like to have the check for matrix properties. In order to have the number of dimensions of a matrix, simply we call the dim function for each matrix that we want. So for example, here for the matrix by row, I call this function, and it's going to print this for us in the output. Sorry. So we are having 2 rows and 3 columns. So the first number is for the number of rows, the second number is the number of columns. But how can we see it in the output? Because I call the dim function in parentheses of the print function. Okay, so this is going to, the cat is going to print the output for us. So we see that dimensions, it's in quotes. So this is the message being shown here. And then I have the column, so you see the column, and then I separated by a comma from the second part, in which I have the call of the dimension function still in the cat function. Okay, so we see 2 and 3 in the output, and \n is going to let the compiler knows to go to the next line when you are printing anything else. Then, in order to understand the number of rows, I call the end row function for any matrix that I want. So it's going to print number of rows, which is number 2, which is true. So number of rows, this is the message that I wrote in the column, in the code, sorry. And all of this is also inside the cat function. So number of rows of the matrix by row is number 2. We have the cat function number of columns here. This is the number of columns message, and then ncall is going to help us to find the number of columns of this matrix by row. So number of columns, it's 3, which is true. So we are having 2 rows and 3 columns, 1, 2, and 3. And then in order to understand the number of elements that are inside this matrix, simply we call the length function for the matrix, and we see that the total length is 6. So in this video, we learned how to fill a matrix by row and by column, and we learned how to check some matrix properties, namely dimensions, number of rows, number of columns, and length. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we would like to learn how to create matrices in R. So first of all, we are having our matrix 1. This is the name of the matrix that I am choosing there. And then I am calling the matrix function to create my matrix. Okay. So I would like the values to be from 1 to 9. And I would like to have 3 rows. So this is the end rows, in end row, meaning that we are having number of rows here. So it equals 3, and number of columns also it equals 3. So we are creating a 3 by 3 matrix that is filled with numbers from 1 to 9. It is assigned to matrix 1. And then I use the print function to have this message being shown firstly, which is here. Okay, 3 by 3 matrix from 1 to 9, and then I print matrix 1. So we see 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of them are being shown here in the output. Okay, so then I would like to have the creation of a matrix with the specific row and column names. So here, as you see, we are having the column names as 1, 2, 3, and 1, 2, 3 to be the names of our rows, in fact. But now I would like to have their name modified and customized. Again, I call the matrix function. This time I would like to have these values in my matrix. So I use the C function to have these numbers for my matrix. Then I mention that I would like to have 2 rows. Okay, so when I have these numbers, so I have 6 values, and I would like to have 2 rows. Therefore, the compiler understands that we're going to have 3 columns. Okay, because the number of elements divided by 2, so 6 divided by 2, it will be 3, so there will be 3 columns there. So now how can we name the rows and columns? In order to name them, simply we are having the dimension names or dim names there. It equals a list in which we are going to have the name, the customized names for our columns and rows. So I use C to have row 1 and row 2, and then I use C again to have column 1, column 2, and column 3. Okay, so whenever you want to name them, firstly you need to name the rows, and then the name to name the columns. And before you're putting the names inside parentheses, just go for the C keyword. It's going to help you to customize the names. And all of this on the right hand side, as you see here, all of this is assigned to matrix 2. Then I have the matrix with row and column names message being printed as you see it here. Okay. And then after that, we are having the print of matrix 2. So when I have the print of matrix 2, I see 2, 4, 3, 1, and 5, 7. So 2, 4, 3, 1, and 5, 7. Exactly the numbers that we specified there. So as you see, we are having 2 rows and we are having 3 columns. Exactly. And the names are exactly the ones that we decided. Okay. So row 1 and row 2. I could say, for example, student 1, then student 2 as the name of our column. So when I rerun the code, we see that student 1, this is the row for student 1, this is the row for student 2. Then it could be, for example, the first one could be math, for example, the second one could be X, the third one could be Y, for example, different subjects. And when I run the code, you see that student 1 in math, the score is 2, in X it's 3, in Y it's 5, and for student 2, the numbers are different. So basically, this is how we can create a matrix in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we would like to learn about a few functions for matrices. So we would like to learn about transpose, diagonal, determinant, inverse, and dimensions. How to calculate these for a matrix in R. So first of all, I'm creating my matrix that is called mat. And these are the values that I would like to have in my matrix. And I would like to have 3 rows. So how many values do I have here? So there are 9 values there divided by 3 rows that I want, meaning that it results into having number 3, which is the number of columns. So the compiler is going to calculate the number of columns this way. Number of elements divided by the number of rows that we specify, and it is going to understand 3 columns needs to be there. So first of all, I'm going to print the mat matrix. So we see that here is exactly what I wanted to have. So 2, 4, 3, for example, 2, 4, 3, 1, 5, 7, and 6, 8, and 9. So this is the original matrix. Now I would like to calculate the transpose of this matrix. Simply, in order to do that, I firstly print this message transpose in the output. Then I have the t function called for the mat matrix. So t function, and then inside parentheses, we write down the name of the matrix. It is going to calculate the transpose of the mat matrix, and all of this is inside the print function. So we are going to see the transpose of the matrix mat in the output. And the transpose means that, for example, we are having the first row here 2, 1, and 6. It becomes the first column 2, 1, and 6. So here the original matrix has the second row to be 4, 5, and 8. And here in the transposed version, we are having the 4, 5, and 8 as the second column. And also the last row became the last column in the transposed version. Now I would like to know the diagonal. In order to calculate the element, in order to know the elements in the diagonal, we are going to simply call the diag function, which is the simplified version of diagonal, for the mat matrix, and then we are going to print it in the output. So we call the diag function for the mat matrix, and all of this is inside the print function. So we're going to see it in the output. So these are the elements in the diagonal of my matrix 2, 5, and 9. So 2, 5, and 9, they are on the diagonal of my matrix mat, original matrix, and they are being shown here in the output. And in order to calculate the determinant of a matrix, simply we call the det function for the mat matrix. So if you have multiple matrices and you want to have, for example, the determinant of a matrix called X, you simply call the det function to calculate the determinant, and inside the parentheses you write down the name of your matrix, for example X, Y, Z, whatever. So in this case the name of my matrix is mat, so I put the name mat there in there. So det for mat matrix, and all of this inside is inside the print function. So we see the determinant is 44 being shown there in the output. And also, in order to inverse my matrix, which is valid for square matrices, or which is also the case for us, we are going to have the solve function to calculate the inverse of the mat matrix. So when we are looking at the output, we see that here is the calculation of the inverse version of the mat matrix in the output. So this is how it is being shown there in the output. And finally, in order to know the dimensions of my matrix mat, I call the dim or dim function coming from the dimensions for the mat matrix, and I print it in the output, and it says 3 and 3, meaning that it's a matrix of 3 by 3, meaning that 3 rows as you see here, and 3 columns, 1, 2, and 3. So basically this is how the functions would work in matrix in R. Thanks for watching. Hello everybody and welcome to this video. In today's video we are going to learn how to do column binding, row binding, and diagonal combination of two matrices. So here I create my matrix 1. I have numbers from 1 to 4 and I have 2 rows. So it will lead to a 2 column as well, because I have 4 elements here divided by number of rows, so the number of columns will be calculated to be 2. Then here the matrix 2 called mat2 is being created, numbers from 5 to 8 and 2 rows there. So I print these 2 matrices in the output. So I have 1, 2, 3, 4, and then I have 5, 6, 7, 8 as to be mat2. So this is the mat1. This is mat2, exactly as we wanted. Now I would like to combine them, let's say, by columns. What does it mean? It means that I would like to have first a new matrix. First I have 1, 2, 3, 4, and here I have 5, 6, 7, 8. Okay, so I have 2 rows but 4 columns. This is combined by columns. So looking at the output, I have, this is the new matrix, that is the combined version by columns of the first 2 matrices. So 1, 2, 3, 4, these are the elements of the first matrix, and then 5, 6, 7, 8, these are the elements from the second matrix. So you see that here I combine them by columns. How can I do that? So I have the C bind, which is combined by column. So column bind, let's say, of mat1 and mat2, and I print them, so I see them here in the output. So mat1 and mat2, as you recall, they are the names of our matrices. Then I would like to have the row binding. So row binding means that I have 1, 2, 3, 4, and then 5, 6, 7, 8. So I have 1, 2, 3, 4, and then 5, 6, and 7, 8. Okay, so this is the row binding, as you see it here. So I have 4 rows now and I have 2 columns. In order to have that, I have the R, which is row, R bind, and for mat1 and mat2 I print them, and you see it here in the output. And then I would like to have the diagonal combination. In order to have that, so firstly let's look at the output. So we are having 1, 2, 3, 4, which is mat1, the first matrix, and then 5, 6, 7, and 8, which are the elements of the second matrix. So this is the diagonal combination, because the diagonal of the first matrix, which is 1 and 4, is aligned with the diagonal of the second matrix, which is 5 and 8. So we created a new matrix here as you see, with the diagonal of the first matrix and the second matrix. Okay, so in order to do that, simply we are having the B DIAG B diagonal for mat1 and mat2, and we call the matrix column. So this is the scope resolution of the B diagonal mat1 and mat2 for the matrix, and this is the actually calling the matrix package. We need that, don't forget to do that. And all of this is inside the print function, meaning that we're going to print them in the output. So in this video we learned how to create two matrices, how to have the combination of them by columns and by rows, and diagonal combinations. Thank you for watching.